Today, we're going to dive into a little bit of carving a canyon. And so, yesterday and the day before up at the Grand Canyon, I know we got a chance to really talk about a lot of things, especially related to the flood and the depositing of those layers and the significance of it. Today, I want to really dive in with you guys a little bit more, a little deeper, if you will, about the carving of the Grand Canyon. And we got some great pictures and some things to show you guys that go along with that. So hopefully it'll give you a little bit better understanding of how we see the Grand Canyon formed. And so that's what we'll kind of dive into today. Again, we talk about the Grand Canyon in relation to the flood in Noah's day. And a big part of that are the layers that we were able to see the last couple days up there on the rim. And so when we're talking about the sedimentary layers, yesterday when we were walking out there, we talked about the Tapeats sandstone, that bottommost layer of the flat kind of horizontal layers that we see of the sedimentary rock. From then all the way to the top, we believe those layers were deposited by that flood in Noah's day. And then, of course, there's a canyon that gets cut down into those layers. And so that's what we're going to focus on now is really how did those layers get carved out? What was the carving mechanism of that whole event? And so I'm going to start my little PowerPoint here and we'll jump over and see if we can get you guys to be able to see this. So one moment here. Let's see. All right. Can you guys all see that?
No. No, sir. Yes. Yes.
There we go. Fantastic. So yeah, we'll dive in talking about carving the Grand Canyon here and the layers that we see and some of the features that we find there from that big event and carving down through there. So we'll talk a little bit about the evidence that we see for a rapidly formed Grand Canyon and again, having to do with a lot of what we see and what we teach at the Grand Canyon on all of our different tours that we have. So last couple of days, we've been able to see the Grand Canyon and to study it. And we talked about the fact that the Grand Canyon is about 277 miles long, averages 10 to 18 miles wide from side to side. And then on average, from the rim down to the river, you're about a mile deep in that place. And so this kind of shows you an outline of the Grand Canyon. Starting way up there in the top right, we see Lake Powell, made by the Glen Canyon Dam back in 1963. And then about 277 river miles or so, the Grand Canyon, we get to Lake Mead on the far western side. And Lake Mead made over there by the Hoover Dam back in 1935. So, of course, between these two big man-made lakes, we have the entirety of the Grand Canyon here in the great state of Arizona. Like I said, 10 to 18 miles wide, over a mile deep, 277 miles long. And so last couple days, I know we've been able to experience and enjoy that canyon. And so we want to talk really about the carving of the canyon. So if we were to zoom out just a little bit further, and you can see on this map kind of in the center down near the bottom, that little squiggle looks like a W. That is, again, the entire Grand Canyon. And you can see it in relation to the surrounding landscape and everything that we have around there. So when it comes to the formation of the Grand Canyon, there are a lot of different ideas, a lot of different theories that have been proposed over the years. Some of the earliest theories, actually going back to the 1800s, some geologists would say the Grand Canyon appears to have been carved out catastrophically and rapidly by a lot of water spilling through there. Now, interestingly, because that's kind of our idea and our theory that we hold to and what we teach the Grand Canyon with Canyon Ministries, a lot of water in a little bit of time, you might say, would carve out this canyon. And so we'll talk a little bit about that because after that, other ideas came about, and some geologists would say, well, maybe the canyon was slowly carved out by the Colorado River. Given millions of years of slow, gradual time, they could say that slowly the canyon was, carved out. The sediment was removed by the Colorado River like a giant conveyor belt, carrying all that material out of there. However, once again, nowadays, there are a number of geologists that believe the Grand Canyon was not necessarily carved out by that Colorado River, but some evidence shows us that it was carved out by a lot of water. Again, going back to some of the original ideas of Grand Canyon formation. And so really, that's what we're going to talk about today is the carving of the canyon, how we see this place being formed. And so one of the great evidences that we like to look at when we look at especially things like satellite technology, we can see some pretty good evidence that there were some pretty big shorelines that held a massive lake system. So if you were to look at this picture here, of course, you can see the Grand Canyon. But if you were to zoom out a little bit further, and if you were to kind of look at the terrain lines and things like that we have, there's pretty good evidence we had actually a massive lake system that kind of set in the middle there. So if I kind of go back and forth, you can see even kind of the outline, you can see the natural place where this lake would form. And so this is something that's been identified with satellite technology, and you can really see it well when you go, and even on Google Earth, you can see where these lake basins used to be at. And these lakes used to sit in the middle of what we call the Colorado Plateau. Now, the Colorado Plateau I've kind of outlined in this kind of yellowish section here. This is an uplifted plateau, an uplifted landscape. And the Colorado Plateau is actually shaped kind of like a giant bowl with a big rim of mountains and highlands, kind of highlands all around the perimeter. And like a giant bowl, naturally, if you start to pour water into that bowl, it's going to collect in the middle, which is exactly how we see these lakes being formed. Basically, snowpack, glacial activity, things like that, that are melting back into this basin and filling it up. Now, again, we have a huge basin, and when you look at this huge basin, pretty much for the most part, all the rivers and streams flow inward to the middle of this giant bowl. But we do have one big crack, you might say, one big escape route, if you will, that the Colorado River drains through and collectively drains a lot of other water on the plateau. And of course, that one giant crack, the one crack in the side of the bowl, if you will, is naturally the Grand Canyon. And so that Grand Canyon you can barely see on this picture, but if you were to look kind of down here on the kind of western side, you can see over here, this is where the Grand Canyon is. So the entire Grand Canyon running from right about here over to here where Lake Mead is at. And so we've got this entire plateau, a small Grand Canyon by comparison, you might say. So when we look at this, this is a huge, massive lake system. Some estimates have placed this lake being thousands of cubic miles in size. And so I've got a little video clip here, and I'm not sure how well it'll show up where you guys are at with your internet there, but we'll kind of zoom in and especially look at the size of the Great Lakes compared to the size of these lakes at their maximum height, some have estimated. We're talking about a massive, huge body of water, a massive, huge lake system. Again, hundreds of square miles, a couple thousand cubic kilometers or cubic miles, you might say, of volume and size for these lakes. So we're talking about a really massive, huge lake system, a really big body of water. And so panning across here, you can kind of see just how big this water was. And then we'll zoom back out here, give you guys a chance to kind of see where that Grand Canyon is in size and comparison. Again, big, huge lakes, and we'll kind of zoom down to the kind of lower left corner here, show you guys that Grand Canyon in size and comparison. The Grand Canyon, as big and as grand as it is, it's really not that big compared to this big, massive lake. So this is something that we've been looking at and talking about for many years, back in the 80s, especially within creation geology. Guys like Dr. Steve Austin really did a lot of work investigating this. Another PhD geologist or PhD guy, Ed Holroyd, did a lot of work with him as well back in the early days. And in 1994, 95, Steve Austin published his book, Grand Canyon Monument to Catastrophe, which really helped outline this big, massive spillover or, breach dam idea, which is not just a creationist idea. There are actually a number of actual everyday geologists that also hold to the same idea and think that this makes a lot more sense. So one of the areas that I've been working on for the past 4 or 5 years has been an intense research project in one of the areas of this lake system, one kind of lake that we identified, kind of three, maybe four different lakes all tied together, but one in particular really to the east of Flagstaff, and that is what we call Hopi Lake. Sometimes it's also called Lake Bidahochi. And so Hopi Lake or Lake Bidahochi is what you see outlined with this blue section here. And so Flagstaff on here, this is where Flagstaff is at. This is where I'm at right now, and this is where you guys are at right now over here by Williams. And so this whole lake system that we see here, this Hopi Lake, Lake Bidahochi, has been one of the areas that we study, specifically because it's so close to Flagstaff. It is easy to get out there and do some field work and some surveying. But also it's one of the ones that, we do a lot of our tours in some of those areas as we go around and do different tours through different places. So again, we get a chance to really see and study it. Just a couple weeks ago, we were out there into the Hopi Buttes area, right around here where the shoreline areas were at, investigating some of the lake deposit sediments called the Bidahochi Formation. And so I was privileged to take Dr. John Whitmore and his geology students from Cedarville University in Ohio. They came out and we went out here and spent the whole day in this region looking at volcanoes and looking at lake sediments and looking for fossils and all kinds of fun stuff. And so this whole lake is kind of really what I'm going to focus on in talking about today, and evidence for this big lake being a pretty good sized lake. Now, some geologists would look at this lake system and they would say, oh, that lake doesn't hold enough water. That lake wasn't big enough. And so there's been a debate, even in the secular geological community, about this big lake. And one of the research papers that I worked on with Dr. Steve Austin and a few other guys really was talking about this exact lake. And the title of that talk that we gave in the 2022 Creation Geology Society conference was, does Hopi Lake hold water? Does this theory hold water? Does it make sense? And so presenting some physical evidence for that big, massive lake. Again, the Colorado River carving the Grand Canyon over millions of years, in our opinion, does not make sense. What we see is that a huge amount of water carving it rapidly, a lot of water in a little bit of time would do this. And so, in our perspective, this would take place after the flood in Noah's day, after the flood deposited all the sediment and those layers were deposited and they were starting to firm up. Then we believe near the end of the Ice Age, there was a big, massive lake that breached through the Kaibab Plateau and carved out the Grand Canyon rapidly. So we'll talk a little bit about that. So this idea of Hopi Lake and Lake Bidahochi, this whole thing is, again, not a recent idea. It goes all the way back to the 1800s, like I told you guys. One of those key geologists that came out here and surveyed this landscape was a guy named John S. Newberry. And so Newberry came through here and he surveyed this whole landscape. He walked across this entire Bidahochi Basin, surveying, where this lake basin was at. He proposed ideas that, hey, it seems to be there was a lot of water that may have spilled through here. And he was one of the first to really recognize that this big basin seemed to have held a huge ancient lake. And so this idea of spillover drainage was published back in 1861. And this is before guys like John Wesley Powell did his famous expedition voyage through the Grand Canyon in 1869. And before the idea of the Colorado River carving the canyon came about, the idea of Hopi Lake and its existence and the big size that it was really goes all the way back to about 1858. And so pretty interesting, some of the history. Again, the idea that the Colorado River carved the Grand Canyon is still simply just a theory held by scientists and some geologists because nobody was there. There are a number of scientists and geologists that actually don't hold to that idea and see it, again, some of the evidence rapidly. So the Bidahochi Basin, the Bidahochi Formation in particular, is one thing that we focus on. And so if you're driving out to the Hopi Buttes area, this is kind of where this lake was depositing some sediment, you would find a tremendous amount of lake sediment. And this is a picture you see here of a location out there called White Cone. And this sediment kind of has the lower member, the middle member, and the upper members of the Bidahochi Formation. And it shows a tremendous lake deposit. And so this really is a ancient lake bed that we're looking at. One of the neat things that I did with John Whitmore last couple times he came out here and brought his geology team is his background, his PhD research work really is in lake sediments. He did a lot of his work up at the Green River Formation up in Wyoming in those regions. So he's quite familiar with what lake sediment should look like. And so as we're walking around out here, we're looking at stuff saying, oh yeah, there's tremendous. This is lake sediment. This is lake sediment. It's pretty well undeniable that this is a freshwater lake bed that we're walking through and examining. And when you look at it up close, like you can see here, what you'll find is that some of the sediment you find is kind of found in the form of greenish looking clays. It also has samples in there of lake mollusks and freshwater mollusks and other animals and creatures. There are fossils in there that come from, fresh water. And so pretty good evidence. Now, the greenish lake clays, like you kind of see here, and like you see here, those greenish lake clays are pretty indicative of a deep water environment. In other words, they were deposited in a deep body of water because greenish lake clays show that there wasn't a lot of oxidation, so that indicates that it was a deep water environment in which they were deposited. Again, some geologists would say the Hopi Lake didn't have much water. Maybe it was just a shallow little lake, and they're trying to push out the idea that this lake system could have carved Grand Canyon. But the physical evidence, when you go and take a look, really to me says the exact opposite. And there are other geologists. This picture comes from one of the research projects that Dr. John Douglas, one of our geologists here in Arizona, did. So it shows a picture. John Douglas and Brian Goutier came out there, and I believe he was part of that, went out there and took a look at this region and surveyed stuff. And they've got a collection of papers that outline some of the fossils that were found and all kinds of stuff. And they're doing this from a non-creation perspective. You know, they're not necessarily creationists, but they're looking at the same evidence and they're coming up with a lot of the same or similar conclusions that this appears to be a big lake system. And so, interesting, another evidence that we see, some of the field work that I've done in identifying some sediment formations, like you see here, it appears to be tufa. And so tufa is a kind of a calcium carbonate deposit, basically kind of an evaporate deposit that you find. This is kind of found around the lakeshore edges that we're looking at. And so tufa is pretty good indication that there was a really big body of water and evaporation took place to kind of deposit some of this kind of calcium carbonate. Another example that I found out there shows some laminated bands within there. You can see all of these kind of lines. The bottom section of this rock, this is actually basalt. This comes from the San Francisco volcanic field area. This is just north of Flagstaff. So this whole blackened rock section, this is actually a big chunk of basalt. And then on top of that, you have, again, the same kind of laminated tufa, you might say, laminated calcium carbonate deposit, kind of stromatolitic tufa, we kind of call it. And this indicates that there was a period of time of water coming over, then drying up, and then another band of material, another band of material. Now, interestingly, this whole section of the rock sits on top of this lava, and it goes opposite of the standard geological models, which says all the limestone-like material should have been deposited underneath that, with the Kaibab limestone being the uppermost member that deposits all that carbonate material. And then the lava flows, they would say, happened later. But in some areas, we actually find something very different. We find lava flows, and then on top of that, we find these kind of calcium carbonate, what appears to be tufa formations. And so that again tells us there was something beyond just the Kaibab limestone, beyond that marine deposit. Something else was depositing limestone after these volcanoes had erupted and after this lava had spilled over. Something else was depositing this material on top of there. And so again, it shows us what was depositing it. Well, it was a lake that we believe was left behind there or was trapped and formed in the middle of this big plateau after the Grand Canyon, or I'm sorry, after the Grand Canyon layers were deposited and before the Grand Canyon itself was cut. Because you cannot cut a canyon, sorry, you cannot have a lake if you already have a canyon in existence. So you have to have a lake, and that lake has to be dammed up. You have to have something to contain that lake, and so you can't have a canyon existing at the same time as this big lake. Otherwise, it would never pond up and build up a big lake. It would just simply naturally drain through. So this is some great key research. And next week, actually, Steve Austin is coming back out here. Dr. Steve Austin is coming to do some research, and we're going to do 3 or 4 days in the field doing some more research. And I hope to get him out to the same place that we see where I found this same sort of formation. Here's another picture of it again. Lava underneath here. Same limestone deposit sitting on top of the lava. So again, this indicates big water. Now, another big indication that this lake used to really exist, and this is an ice age lake, is some of the fossils that we find when we go and take a look out there. We find things like you can see here on the left. We find trackways and even fossil bones of things like Canada geese and tundra swans. So tundra swans, this picture here shows you the typical range of the tundra swan. And so naturally thinking, where do tundra swans live? Well, tundra swans live in the tundra where it's cold and snowy and things like that. So this is their normal range, but yet we find evidence of them all the way down here in Arizona. Now, why in the world would that be? Well, that's because we believe that this whole lake existed while the ice age was in place and colder climates were actually pushed down further south. And we did have colder climates here in Arizona. So this zone where the tundra swans typically live would have been pushed further south during the ice age after the flood. And that's why we find these tundra swans. And we find their trackways and we find their bones, we find their fossils around the shorelines of where this big lake used to be. And so to me, that's pretty important to understand because naturally we have big lakes and big bodies of water. That's where we're going to get swans and geese and things like that. Other things that we find in this Bidahochi Basin formation, so other fossils we find are things like beavers, and we actually have some camel-like fossils. So we actually had camels running around North America and or related to them, things like alpacas and llamas. So they're all part of that kind of camelid family, you might say. So we find evidence of that. We also find evidence of saber-toothed cats down here, the Smilodons. And so that's also found in that area, as well as a number of other freshwater kind of ice age type animals. So again, from paleontology, when we study the landscape of this Bidahochi Basin and the Bidahochi Formation, we find evidence of these post-flood ice age animals living in this area, which kind of helps us get an understanding of when this whole event would have happened that we believe formed the Grand Canyon. Now, why do we find some fossils around here? Isn't fossilization the result of catastrophes and rapid burial? And yeah, it typically is the result of rapid burial. We also have, after the flood, a tremendous amount of regional or local catastrophes, you might say. It would take a while for the earth to kind of calm back down from the flood. Even after the flood, and even because of the mechanisms of the flood, we would have still some volcanoes going off for quite a while after there. We'd have uplift of landforms. We'd have things kind of settling and shifting and changing. Psalm 104 talks about the flood, and Psalm 104 verse 8 tells us that mountains rose and valleys sank to the levels that God decreed. So even with the flood, we have a tremendous, catastrophic devastation. But even after the flood, we still have some local regional catastrophes. And that seems to be the case that we're looking at here. We have some rapid sedimentation in places. We even have some areas where we find entire, we call them mass kill sites, where there's a bunch of fish fossils all grouped together in one area, as if there was some kind of local or regional catastrophe that may have, hit this lake while it was there. Could be volcanic, probably in nature, and cause some local regional rapid death and rapid burial to give us these fossils. So we find the fossils, we find the footprints, and another interesting thing that we find with this lake that shows us this was indeed a freshwater lake system after the flood during the Ice Age. We actually find fossil ice crystal casts around the lake. So when lakes are there and if they're freezing around the edges, those can actually create these ice crystals. And when those ice crystals are there, when they kind of melt back, they kind of push into the sediment, but then they can actually melt back. And other sediment, kind of like different softer sediment, usually would fill into that void. And it can actually leave behind a fossil cast, you might say, of ice crystals. And I've seen some of those myself out there in the Bidahochi Basin, in the Bidahochi Formation. And so it indicates to us this is not water that was from the flood in Noah's day. This is not marine. This is lacustrine. This is a lake system, a freshwater lake after the flood and during the Ice Age. So if we had a really big lake after the Ice Age, well, what other evidence should we look for? One of the things that scientists and geologists have been asking for about this lake is, well, where are the shorelines of this lake system? If there was a big lake, we might be able to find some shorelines that were kind of left behind, like wave-cut terraces. As waves kind of lap up against the land, they can actually kind of cut into the landscape, kind of stepped terraces. And if this lake is continually filling up, you'd have a cut here, and then a cut higher up, and then a cut a little bit higher up. And so you get a series of kind of stair steps of wave-cut action. That has been a question people have been asking and looking for many, many years. And about 4 years ago, doing some survey work in the area, I found what appears to be wave-cut terraces. And so this is exciting because this is kind of like a smoking gun of geology, something we've been looking for a long time. And I had to kind of sit on it for a while to actually talk to some other geologists, try to get their opinions before we could actually start to publish it. So a couple of years ago, when I talked to Dr. Steve Austin, Dr. Andrew Snelling, and Dr. John Whitmore, they all said, "Hey, this looks very, very plausible. We got to take a look at this." And so Dr. Steve Austin said, "Hey, I'm getting on a plane. We're going to go take a look." And so he's come out now a couple times, and again, coming back out next week to do some more survey work. And so what we believe we've identified are some lake shore lines that you can kind of see, hopefully, in this picture. This is a ridge that you see. And this ridge is actually kind of sloped. It goes kind of lower section down here, and it slopes up from the bottom toward the top, going from the bottom right to the top left, kind of sloping up an angle. And if you look carefully, what you might be able to see are some lines going across there that appear to be these kind of wave-cut terraces. Sometimes people call them strand lines, but these very much match what we see with other shoreline terraces from other known lake systems. And so again, if you plot the elevation of this area, you can actually see that it goes up in this direction. This is kind of the elevation starting at the low point, which is way down here, going to the high point. Imagine a lake filling up and up and up and up. And as it fills up, it actually creates these kind of wave cut terraces, probably from annual inflow to this big lake. So during the winter, the mountains and this whole giant Colorado plateau have a lot of snow and ice pack. When that stuff starts to melt back in the spring and early summer, well, all of that water comes rushing in and fills these rivers, and these rivers dump into this lake, and so it rises up to a notch, and it kind of stays there filled up, and then the next year it kind of rises up again. So you have a continual rising. And so when we look at the elevation, this is kind of elevation plotting map. The lower blue and green colors are the lower elevation. The orange and red are higher elevation. The elevation mapping of this actually matches this exact thing that we would expect to find. This is where we find these lines that kind of go right across here in the same orientation that we would expect to find if we did have this lake filling up. Now, a couple years ago, I took my drone out to this area and actually did some drone work kind of looking at this. So I'll show you guys this little video clip here. Again, hopefully it'll work where you guys are at. It may be a little choppy for you. But zooming up into the air to actually look at it, to see what it looks like, you can begin to see these lines as we pan out here. You can see where these lines, these shorelines, are seen on the land, still seen to this very day, in fact. And so we've done a couple of times going out there doing some actual survey work, plotting out all of this, and we put together a pretty good paper and presentation at this last year's International Conference on Creationism. So we had Dr. Steve Austin actually present the paper, since he is the lead geologist on our team for that research project, and came back with some pretty good responses from the creation geology team and creation geology community, I should say. And again, coming back out next week, we're going to do some more work in this landscape, doing some good survey work and things like that to really try to work more on this, because this could actually be a very intriguing paper and presentation. And so we're working to get it published in even the secular literature. This is a nice view showing you the Bidahochi Basin, kind of this whole lake bottom basin. So basically all of this area you see here would have been underwater as part of this big lake. And so this is a big, massive lake basin that we're looking at. And then panning down a little bit, you can see where some of those shorelines were at down below us. Pretty neat. This is actually a little bit west of Flagstaff. So you guys, as you're coming out here from Texas, probably drove right past this location, in fact. And pretty neat location there between Flagstaff and Meteor Crater, actually. So pretty neat. So when we look at this big lake system that we have here, one of the interesting things that we want to kind of identify and talk about is, with a big lake like we have here, some people have said, well, maybe it was just a shallow lake and maybe that lake just eventually dried up and evaporated and left the landscape. Well, we know that's not the case. We know it wasn't simply just a lake that evaporated, because if that was the case, we should find a lot of lake evaporated deposits. You know, big lakes leave behind a lot of what we call salts and minerals. So, for example, if you were to drive out to by the Great Salt Lake, a little bit west of there, we have the Bonneville Salt Flats from ancient Lake Bonneville. Well, a lot of that area has dried up, and that drying up of that lake has left behind really big salt and mineral deposits. So much salt out there, they actually mine the salt, and it leaves behind a big, natural, massive salt deposit, salt plain. Well, when we look at where these other lakes were that we proposed, there is no major salt deposits. In other words, it appears the lake water was there, and then suddenly it wasn't. It disappeared, basically. So, of course, the question is, where did all of that water go? Where did it end up? And again, when we look at the whole Colorado Plateau, there's only one major exit route, only one major drainage, you might say, that water could escape. That one crack in the side of the bowl happens to be the Grand Canyon, which you can see here. So here's kind of what our proposal is, a before and after picture of these two big lakes. There's a kind of shoreline area where the lake would rise up, would be trapped by the Kaibab Plateau, the kind of greenish section you see here. Eventually, the water either rose up high enough to start to spill over a low point, or maybe an earthquake or some kind of shaking of the ground triggered some kind of breach, or maybe tunneling through some of the limestones, through some of the karst formations. One way or another, this began to breach, and as it began to breach, water started spilling over this plateau. And as water started spilling through, more water means more erosion means more water. Pretty soon, you end up with a catastrophic exponential runaway process that would drain this entire massive lake system very, very quickly. And the aftermath result is a breach that the lake would spill through. So you would really say that the draining of this lake created its own escape route. It created its own breach that we call today the Grand Canyon. Again, thousands of cubic miles of water spilling through, draining through, carving this canyon very, very rapidly. And so here you can kind of see the combination of all those lakes that were part of it together. Three to maybe four lakes. This lower section, this is Lake Bidahochi, Hopi Lake. Other lake systems up here that would be tied into all the way up into Utah, perhaps, up to Lake Uinta up at the very top. We're talking about a lot of water. And so looking at this big lake system, we can actually start to look and see kind of where the lake would drain in at. So if we zoom in, we can start to see the Grand Canyon and where the little Colorado River Gorge is at. This crack you see leading into the main Grand Canyon, this is where the Hopi Lake or Lake Bidahochi would have drained into. And you can actually see kind of multi-fingered channeling coming in, multiple little side canyons are kind of leading into this main canyon. This would be the breach point for this big lake draining into there. And so this is on the eastern side of the Grand Canyon itself. And again, this is where Hopi Lake or Lake Bidahochi would have drained through. Pretty spectacular drainage point draining into the main Grand Canyon. And then joined together from the north, from the other part of the lake system that would drain in from the north, creating what we call Marble Canyon up in that area. So, what other evidence do we find for this big lake drainage, this big breach? Well, a couple projects that I've done out near Wupatki show some pretty interesting features. So first of all, when we're out there in Wupatki, we find things like this giant remnant boulder sitting up all by its lonesome, up on top of a big hill, and it's completely out of place because this boulder should not be there. It actually sits on top of other sediments that normally are deposited on top of it. This is kind of a remnant boulder that's been plucked up and carried and removed and left behind on top of this landscape. And so this is kind of a very interesting thing. Another interesting feature we find are all these rocks you see kind of glued to the side of it. So these are all kind of pebbles and rocks that are glued to the side of this big boulder, and some of them are left behind on top of it. And they're really, I say glued together. They're glued together by what we call calcite. And so this white mineral you see here, this is calcite. This is kind of like calcium carbonate material. This is actually glued together. Some of these surrounding rocks and pebbles kind of glued them onto this boulder. Now, why have they glued them onto there? Interesting thing is, when I look and survey this boulder, they're only found glued onto one side of it. They're not really found on the other sides of it. They're not really found on the front side. They're glued onto this side. And if you were actually to plot this boulder and where this kind of orients itself, it actually goes in the exact direction toward where the lake would be draining into. It follows the path that this Hopi Lake would be draining toward the Grand Canyon. In other words, all this water current pushing behind it are pushing all of these rocks and all of this stuff against it, and it's kind of cementing onto there, leaving behind some of these rocks left behind on these boulders. Another indication of a lot of water spilling through here and draining past this boulder is on one side of it, we actually see these kind of banded calcium carbonate deposits that we see from flash flood deposits. This is not the natural, you might say, bedding of this boulder. It's actually, you can see here some cross bedding, part of the natural bedding, and it's more straight bedding. This is actually calcium carbonate deposits. I've actually done testing on it to show that it's a calcite deposit sitting on top or sandwiched or glued to the side of this boulder. And so this indicates that water was rushing through here and depositing bands of sediment onto the side of it, the calcite deposits. On other sections of the same exact boulder, we find very curious lines like you see here. What we're looking at, most of these are actually big scour marks. These are happening when big rocks and other boulders are actually scraping up against and rubbing up against this one boulder. And you can see gouge marks like you see here. These are big gouge marks that are left behind from other big rocks and boulders scraping the sides here. And again, when you start to orient all of this, you start to kind of plot the direction that all this is pointing to. It's all pointing toward the Grand Canyon, as if all this water was draining beside it and around it and pushing it in a certain direction. On top of these boulders and nearby also, we find a lot of rocks that are seemingly oriented in the same direction. And it's kind of hard to see, but if you look closely, a lot of these pebbles are up on end. They're turned up on end. They're kind of oriented in the direction of the water flow that was going toward the Grand Canyon. And so they're like rolling rocks. So it would be rolling because they're rounded, almost like if you ever take a quarter and kind of roll it across the ground, it kind of does that same thing. And so looking at those same rocks, we can actually see that they've been oriented toward the direction of flow toward the Grand Canyon. So again, this is all taking place after the flood, and this material is being carried across this landscape by this other lake system, a smaller flood, you might say, that's draining toward the Grand Canyon. And a lot of these same sorts of rocks and material we actually find in the Grand Canyon itself, especially kind of left behind and set down in areas that normally don't belong there. Like a lot of these rocks that you see, these rounded rocks, they are not natural to the Grand Canyon itself. They come from a completely different area, it appears. But they've been all set down on top of these hills and slopes in a very interesting place called Furnace Flats. These big flat open areas. This appears to be material that was being carried from the surrounding desert as this lake was draining down into here and then left behind on the surface of this. So we hiked up here a couple years back and examined it. And I'm going through, and I've been, like I said, I spent about 1,000 days in the Grand Canyon National Park studying it and leading tours. Dozens of river trips through the Grand Canyon and never seen these kind of rocks anywhere. All of a sudden, we're coming across rocks like you see here. This does not belong in the Grand Canyon. It's not part of the Grand Canyon sediment. This is a completely different foreign rock, you might say. This doesn't belong. So the question is, how did all these rocks like this get there when most of these you're seeing here are not part of the natural Grand Canyon layers? They are not part of all the sedimentary layers you see in the Grand Canyon. And at this point, we're not even into the depths of the Grand Canyon where you see the metamorphic and igneous rocks. This is up around Tanner Rapid and a little bit below that around Cardenas. So this whole area is much further upstream than where all these different types of rocks normally could be found. To me, it says, these rocks seem to be something that was brought in as the canyon was being carved. This was washed in by a tremendous amount of water. Other interesting things we find in that Bidahochi Basin are random limestones like you see here. This is actually a big hunk of Kaibab limestone that's been left behind. And this is sitting up on top of a hill that's about 100 feet above the nearby Little Colorado River. Now, the curious thing about this limestone block and this limestone block, these limestone rocks are sitting on top of the Moenkopi, and some have identified as sitting on top of even what we call the Chinle Formation. Now, this is very interesting because if you know the geology of the region, the Kaibab limestone is found underneath all of that. So we'd have Kaibab limestone, then the Moenkopi, mostly sandstone, and then on top of that, we begin to get the Chinle Formation. Yet these are erratic boulders, you might call them. These are not where they normally belong. These are limestone blocks and chunks of rock. These are big boulders that are completely out of place. They're sitting on top of these other two layers. So the question, of course, is how did that limestone get there? It appears that it was carved out as this water was draining through. It was cutting through places like where we have Grand Falls. It actually cuts down into the Kaibab limestone. It appears that catastrophically a lot of water was spilling through there, perhaps cutting into that landscape, plucking up rocks from lower elevation and then carrying them to high places, leaving them abandoned, sitting on top of these other locations. So it's interesting research when you begin to look at this. This is very fascinating stuff that we're talking about for a big lake. So the idea when it comes again to Grand Canyon Formation, we're talking about a lot of water in a little bit of time, a catastrophic amount of water, if you will. And that amount of water spilling through the Grand Canyon would carve it very rapidly. Again, we've seen the Grand Canyon the last couple days and how big that is. The volume of the Grand Canyon is about 950 kilometers, so 950 cubic miles in total volume. So about 950 cubic miles in total volume, but these lakes are thousands of cubic miles in total volume. So we're talking about a lot more water in these lakes than what the Grand Canyon itself has in volume. We're talking about a lot of water rapidly spilling through here, coming through, cutting through very, very quickly. A lot of water in a little bit of time. So, of course, when thinking about that and talking about that idea, one of the things that we really try to focus on is the Grand Canyon does not need millions and millions of years of slow carving by the Colorado River to give us what we have. And a lot of people would say, some evolutionists, atheists, some would say, you guys that believe in the Bible, you believe in creation, you believe in the flood, that's all ridiculous. There's no way the earth is 6 to 8,000 years old when we know things like the Grand Canyon were carved carved over millions and millions of years by the Colorado River. There's no way that it can be that young. Well, if there's another mechanism, another idea by which we can get the Grand Canyon carved rapidly and catastrophically, now we don't need the millions of years by the Colorado River. We can do this very, very quickly. And so when we look at the Grand Canyon, we look at this landscape, again, to us, it showcases not only the beauty that God reveals in that landscape, like we talked about yesterday, not only the beauty that He's created from the destruction of the flood and from all the depositing of these layers, it also shows us that we don't need the millions of years, and there's really good mechanisms and understanding behind that. So we examine the Grand Canyon, we look at the evidence of the Grand Canyon and show this is a monument to catastrophe, we would say. And again, a lot of water in a little bit of time. We would also say the Colorado River that we see down below today, the canyon was not carved by the river. The canyon was carved rapidly, and the river just continues to flow through there today. Why do we have a river? Well, because we have an escape route for all that lake water that normally would pond up and make a big, huge lake. Instead of ponding up, it's actually now draining through, and it continues to drain through. If we put a dam in the Grand Canyon, dammed it up, we would easily have a huge lake once again. And in fact, a couple different places, we've actually dammed up the Colorado River, haven't we? We've made Lake Powell and Lake Mead from that exact same river. But again, when we look at this big landscape, this shows us that there is a river, a canyon, not because there's a river, but there's a river because there is a canyon. The canyon came first, we believe, and the river just continues to flow through there. And again, it shows us the glory of God that's revealed. And again, if we didn't have the Grand Canyon, we wouldn't even have the understanding of all of these rock layers and geology to study. And like I told you guys yesterday, I don't believe there's a better place on the planet to see and to study and to understand this flood geology like we see at the Grand Canyon. So hopefully that gives you guys a little bit of insight into Grand Canyon formation and how we see some of this being formed. And so if you guys have questions, I'm going to go ahead and stop the share for a second, and we can dive in. If you guys have any questions that you may have thought about from yesterday or when you were there with Adam, or even now when we're talking about the Grand Canyon formation. So I'm looking back at you guys here. Anybody have any questions? If you do, go ahead and speak up because you're kind of far away from the camera there. But if you got questions, feel free to ask and we'll see if we can get some answers to that.
Right. That was awesome, Nate. Joel has a question. You might need to come up closer.
Yeah. Can you hear me, Nate?
Yeah, I can hear you now.
All right. I love the shoreline the sky view of the shorelines.
Yeah.
I was curious if you had matched, like, so as the shorelines were working up in elevation, did that match up to the breach shoreline there at the canyon entrance at the topmost point? Can you kind of match that to where it breached?
So yeah, interesting thing with that whole area. In fact, let me pull this screen share back up again because I think I can actually share a couple things about that. One of the things that we see is the present elevation of that shoreline where the Grand Canyon is at is actually at a higher elevation. Let me, this might work. So the elevation is actually a little bit higher at the rim of the Grand Canyon today. And it's a higher elevation at the rim of the Grand Canyon today, we believe mainly because of what we call isostatic rebound and an elevation change. So what we see happening is that like when the Grand Canyon is being cut out, imagine this was a, if you had a big block of wood, something like floating on the ground or floating on water, or imagine the land is a big chunk of a big block basically of rock pushing down into the asthenosphere, into part of the mantle. This big block of land would be sitting on top of, more liquefied, movable material. But it works very similar if you had a block of wood in water. And if you were to carve off one side of that block, say you chip away, you carve off one side of that wood block, or in our scenario, if the Grand Canyon is carved out because the all that material is being removed, what happens is if you remove all that material on one side, well, backside would actually push down into the water. The front leading edge would actually be lifted up. So you actually have an elevation change right here at the fulcrum point. You have where this actually becomes higher than what it was before. The back end becomes lower. And interestingly, that's what we actually see at the Grand Canyon in many cases. We actually see that the rim itself is actually at a higher point elevation today than what it used to be in the past. This is seen a very interesting thing we can find. We call isostatic rebound, or kind of a flexural response. So in other words, if you have a lot of weight pushing down, that weight pushing down from the weight of the rock on top is actually balanced by the force of push from underneath. So it's kind of an equal force. Well, if you remove all that material on the top, you scrape it away, remove all the hundreds of cubic miles of rock and dirt and weight. Now the force pushing up underneath wants to push up higher and lift it up. And so we get tectonic uplift. And so this is actually from here to the left. This shows leading from the left upward toward the rim of the Grand Canyon, and then it drops down into the Grand Canyon on the far right. But this entire landform has actually been uplifted, and then it drops down. And so what we see is the elevation we see today is actually the rim is higher than what it was when the lake was there and when the lake breached. And so many times you might see a picture of Grand Canyon looking kind of like this, flat rim at the top, but that's not exactly what we actually see. It's actually more sloped backwards, and it slopes into there. And so the rim elevation today, I would say that rim elevation is at a higher point today than what it used to be in the past. In the past, it was lower and much closer to where this lake elevation was. And so some of the calculations that I've done on the lake elevation based upon terrain matching and shoreline areas, we kind of place this elevation right around 6,700 feet in elevation where the maximum height of this lake was. Then it breached through there. And then after that, the rim lifted up higher so that now today you're at some higher elevations around 7,000 feet. And so it's kind of bounced up, rebounded a little bit. So today's geology can't exactly match what we saw when the lake was here. We have to look at the whole landscape, and some of the uplift has happened since the Grand Canyon was carved out due to that rebound effect of pushing from underneath in response to all the weight off the top being removed. So it's pretty close. And when we actually lower it down to where it should be, we actually do find that it matches up with the proposed height for this lake system. Yeah. Great question.
And excellent presentation. Before I have another one, but before I do, I want to see if any we do from Khalil.
Yes.
Come on, Khalil.
Sir,
Yeah.
was the ice age because of the drastic change in weather of the flood, or is that what happened?
Yeah, absolutely. So the Ice Age has a number of interesting things to it. When it comes to the Ice Age itself, a lot of climatologists are really puzzled by that. How do you get an Ice Age? And more importantly, how do you end the Ice Age? And so one of the things have been proposed by a few researchers and geologists and guys like Michael Ord, who is a very well-known um, in climatology and things like that, put together a model showing that the flood, ironically, actually would create the mechanisms for an ice age. And so one of the questions is, how do you get that much, snow and ice pack on top of the continents to create an ice age? It doesn't naturally happen like that. Well, this would be the mechanisms of the flood. Yesterday, we talked about the fountains of the deep breaking forth, right? So the Tehom, the Bible refers to the deep, would be the deep ocean basins. And the mechanisms we see with an idea called catastrophic plate tectonics has to do with a lot of, magma coming up from the cracks and fissures of where the continents are breaking apart, perhaps in places like that. And where the seafloor is cracking and breaking. And so magma is exposed to seafloors, to seawater, and it creates a giant steam blast of superheated water shooting up as these geysers. These are the fountains of the great deep. But that amount of magma being added to there and continually for this year-long process is also warming the oceans. And so I believe yesterday we talked about how today's ocean temperature average is 39 degrees Fahrenheit, right? But during the flood, it would be about 86 degrees, they've shown. And so this warms the oceans tremendously. So if you have warm oceans, what's going to happen to all that warm ocean water? That warm water is going to increase in evaporation. So that evaporation is going to rise up. You're going to get tremendous amount of moisture coming from the oceans, condensing as clouds above there. And as those clouds move across the landscape, they're dropping tremendous amounts of rain, and in some places dropping tremendous amounts of snow and accumulating so much. In fact, we could have huge, massive post-flood hypercanes, not just little hurricanes, but massive, huge storm systems. Estimates have shown that these hypercanes could dump as much as 100 inches of rain in a single storm. So tremendous amount of rainfall in some places, and in other places, more northerly areas, it would actually produce a tremendous amount of snow. So much snow that it actually accumulates layers of ice, and those ice layers, compact to form massive glaciers, in some cases miles thick. Now, added to that, we've got warm oceans, but at the end of the flood, we'd also have a very cold landscape. Why do we find the evidence of the tundra swans down here in Arizona? Because Arizona in those days was much cooler temperature. It had the habitat for grassland areas. It had the habitat for these ice age, Pleistocene-like animals. And so that's also because the land after the flood would have been much cooler. Now, why is the land cooler? Well, one has to do with evaporation from the land. So the land has been saturated by the flood. The flood waters drain off, but the land is still pretty wet, has a lot of moisture. As that water is evaporating and moisture is evaporating from the land, it's actually cooling down the surface of the land in the same way that when we, sweat, we're really hot, we sweat, and that evaporation cools us down, right? It's a cooling mechanism. That heat energy is lost. It's left from the evaporation. It takes the heat with it. Same thing happens with the land after the flood. The evaporation of the water, so we're draining off there, and the land drying up is actually cooling down the land. But also during the flood, and for some time after that, we see there were a lot of things like volcanoes going off. Those volcanoes in the surrounding landscape are putting tremendous amounts of dust and particles, and we call aerosols, into the atmosphere. The volcanic material, the volcanic dust, is actually blocking out sunlight and is creating a cooling effect. And we've actually been able to measure and record, even in modern history, when big volcanoes erupt, it actually cools down global temperatures. If we had tremendous volcanoes going off for some time, as everything's trying to come back for hundreds of years, we would have a much bigger cooling mechanism. So we have cold land, we have warm oceans. Those warm oceans, again, are increasing evaporation. That's moving over the cold land, and it dumps rain, and in some places dumps a lot of snow. In places that are normally hotter and drier are actually now colder because of the evaporation effect and the blocking out of the heat energy from the sun. So the land is colder, the warm oceans are warmer, and so it creates this ice age effect. But eventually, the dust begins to settle, the sun begins to warm the landscape up, the glaciers start to melt back. The heat energy is lost from the ocean because as all that heat is rising up, the oceans start to cool down. So that process then reverses at the end of the flood. Perhaps 700 or 1,000 years after the flood, we would see the end of the ice age. And so that is now reversing all of this process and mechanism. And so the ice age is now ending, and then that's it. We do believe there was an ice age. We believe it was after the flood. We believe there was really one major ice age, that over those hundreds to 1,000 years, perhaps, we would have different times of, like, advancing in the winters and retreating in the summers, and, glaciers moving and advancing over the landscape. So we do believe there was an ice age, and ironically, it's created by the heat of the ocean from the flood. This has been well modeled and documented, well modeled, I should say, by guys like Dr. John Baumgartner, who actually modeled this whole thing. He put together, he's literally the guy who wrote the code and the software that the European weather modeling agencies use. They still use some of his code to actually predict and to track things like hurricanes and weather patterns all over Europe. So he put together this on these big, giant, massive supercomputers, and he actually plugged it in. What happened if you were to warm the oceans? If you were to warm the oceans up to this predicted temperature, what would happen? And the computer modeling took over at that point. You just put that variable, warm the oceans, put in that variable, and interestingly, that computer model running all these high-end climate programs created an ice age. And so that's exactly what we see from the flood. Ironically, the flood creates the ice age from warm oceans, cold land. And so, yeah, we do believe in an ice age. And so that's a short, short explanation, short talk on the ice age. But again, if you want to look into that, look at Dr. John Baumgartner, and Dr. Michael Ord, who's also done a lot of work. He's done a lot of great things on the Ice Age. You can look into his work as well too. Great question.
Thank you, sir.
Zeke? Come on up. You ask him about the waffles in the canyon? How many waffles?
Yeah, sure. Mr. Kelly was just mentioning the question of some kid asked you about the waffles in the canyon. How many could we get of those? And I have a couple more questions, but
Yeah, about 3.1 quadrillion Belgian-sized waffles. There you go.
another question is approximately how long after the flood did we get that ice age according to that model you meant?
So we're not exactly sure if it was right away or if it took, a few hundred years to actually start up. I would say, some of the guys I've talked to say that we would start to see that ice age really starting to accumulate and becoming ice age within a couple hundred years after the flood. So it could be very quickly. I mean, naturally, as the water's drained away, the land's going to become very dry. I tend to think the ice age started to build up pretty quickly, probably peaking around 500 to 700 years after the flood, and then starting to warm back up and go back down after that.